Hi there, welcome to this lesson on Pure Mathematics 1. In this lesson we're looking at inequalities, and in particular how you shade the region on a graph that represents a set of inequalities. In previous lessons we've looked at how you solve inequalities, but sometimes they ask you to go a step further than that and shade the region that shows your solution. So for example, if you had two inequalities, y is greater than or equal to x squared minus 2x minus 8, and y is less than or equal to 0. If you had to shade the region that satisfies both of those inequalities, first of all, you draw the related function, y equals x squared minus 2x minus 8, and y equals 0. Y equals 0 is just the x-axis, so we don't need to draw anything for that. And the quadratic x squared minus 2x minus 8 would look something like that, with crossing points at minus 2 and 4 on the x-axis, and minus 8 on the y-axis. Then you just need to read carefully what you're being asked to do. So we're asked to shade the region where y is bigger than the quadratic, that means above the quadratic, and where y is less than the x-axis, that means below the x-axis. So the region above the quadratic, but below the x-axis, which will be that region. We do need to be careful on these signs. Sometimes rather than greater than or equal, they'll give you a strict sign. So for instance, they might say y has to be strictly greater than x squared minus 2x minus 8. Now, if that's the case, the region isn't allowed to include the line. It can't be on the curve. And the way you show that is by drawing a dotted line for the curve. So you draw something like this, a dotted line. And that means that the region does not include the line, that you can't actually be on it. Okay, an example for you to have a go at yourselves. Shade the region that satisfies the inequalities. Y is bigger than x squared minus x minus 6. And y is less than or equal to x minus 2. Have a go yourselves, pause the video and come back when you're ready. Okay, let's have a look at this. If I was going to do this, I'd probably do the straight line first, just because it's easier. So the related straight line is y equals x minus 2. We'll do that in the normal way. We'll find the crossing points on each of the axes. So to find the crossing point on the y-axis, we say what happens if x equals 0. If x is 0, y equals minus 2. That's where it'll cross the y-axis. If y equals 0, then x equals plus 2. So that'll be the crossing point on the x-axis. That'll be those 2 points. Because it's a straight line, we don't need to know anymore. We can join those together, and that should be the straight line we get, y equals x minus 2. Then we do something very similar for the quadratic. Again, we say where does it cross the y-axis by saying what happens if x equals 0. If x is 0, then y equals minus 6. And if y equals 0, that means the whole quadratic is equal to 0. Thankfully, that does factorize into x minus 3 times by x plus 2. If the first bracket is 0, that means x is equal to plus 3. And if the second bracket is 0, that means x equals minus 2. So those will be the crossing points on the x-axis, and minus 6 is the crossing point on the y-axis. We know the general shape of a quadratic, so now we can sketch it. You should get something like that. Now we just need to go back to what the question asked us to do. Now the question said that y had to be strictly greater than x squared minus x minus 6. If you do sketch in pencil, it's not a problem. You can quickly rub out bits of the line to make it into a dotted line. Otherwise, you do need to think ahead, but we do need to change that. So we need a dotted line for the red curve, for the quadratic, because y is strictly greater than it. And we're looking for the region above the quadratic, but beneath the green line. Well, that will be that region. So that's what we need to shade. Example 2, slightly harder because there are 3 inequalities this time. Again, I'll let you have a go yourself first. Pause the video. Come back to me when you're ready. Okay, let's have a look at this. I think I'll probably start on the right-hand side because that's the easiest thing to do. X is less than or equal to 2 means we need to draw the line x equals 2. Well, the line x equals 2 is the vertical line that goes through x equals 2 on the x-axis. So that will be the line x equals 2. Then the second line is y equals 2x minus 2. We'll draw that in the normal way. So to find the crossing point on the y-axis, we say what happens if x is 0. If x is 0, y is minus 2. If y is 0, then x is equal to plus 1. So that'll give us those two crossing points on the axes. It's a straight line. We can draw it now, and it should look something like that. And lastly, we need to draw the quadratic. Now there's a minus in the quadratic, minus x squared. That means that the quadratic is going to be upside down. We don't really need to worry about that for the moment, but we do need to remember that it's the case. Again, we'll find the crossing points in the normal way. What happens if x is 0? Well, if x is 0, y equals 8. So that'll be the crossing point on the y-axis. If y is 0, then that whole quadratic equals 0. And this is the point when I would resolve the minus, just to make the question easier. So moving everything over to the other side of the equation, you'd get x squared minus 2x minus 8 is equal to 0. That does factorize into x minus 4 times by x plus 2. And that has two solutions, one where x is equal to plus 4 and one where x is equal to minus 2. We can now plot those 3 points. We know that the quadratic is upside down, so it's no surprise that they're arranged like that. And the quadratic should look something like that. Then we need to just revisit the question and see exactly what they're asking us to do. Now, two of the inequalities are strict ones. So the first one says y is strictly less than the quadratic. That means we're going to need a dotted line for the red quadratic. Also for the straight line 2x minus 2, y is strictly greater than the straight line 2x minus 2. So that'll also need to be a dotted line. The third line, x equals 2, that can be solid because x is allowed to be equal to 2. But changing the other two, we'll get a dotted line and a dotted curve. Then we can shade the region. It's got to be underneath the red curve, it's got to be above the green line, and it's got to be to the left of the line x equals 2, where x is less than 2. So the region in this case is a little bit more complicated. It'll be all of that. Okay, that gets us to the end of this lesson. If you have the textbook, turn to page 53 and have a go at exercise 3G. Thanks very much for listening, and cheerio.